Hello, let's solve some Leetcode today. We have a couple problems here, and it's distribute candy 575. Alice has n candies where I candy of type candy type. Alice noticed that she started getting weight, so she visited the doctor. The doctor advised to eat n of the candies. She has n always even. Alice keeps her candies very much. Likes her candies very much. She wants to eat maximum number of different types of candies. Following the doctor advice, given the integer array returns the maximum number of different types of candies she can eat, n of them. So what we have from the description that we have allowed, let's say total allowed will be, so first we will calculate, it's just what we have described here. We have total allowed, which is len of candy type divided by 2, right? So total allowed will be n divided by 2. My typing is bad today. And we have to return maximum number of different types of candy. She can eat n of them. So this is total allowed, and we have to return max types, right? So so we can calculate types of candies by running counter on candy type, right? But how we will find max types? I believe what we can say max type could be because max type, if max types are, for example, if we have a just we allowed to eat n divided by 2, and we have types as lengths of types, right? If you take a candy for every type, but then so this is what we can eat, right? And then, however, what if max types is more than we allowed? So we can say if max types less, if max types more than total allowed or equal, then what should we do? We should return max types. What if it's less? So for example, like here, we allow to eat 3, one of each type. Like here, we allow to eat 2, but we have like we allow to eat 2, but we have only one type. So if total allowed more than max type, we return max type. Right? Yep. Perfect. Why 19? I don't know. Why 19%? Okay, somebody solve it faster. It's a mystery. Okay, let's see how people solve it faster. So length of candy type divided by 2. Length of set of candy type. And then mean. Yeah. But why do I need length of set of candy type? Yeah. So my getting count, creating counter, and then getting length of the counter, it's the same as getting length of the set, right? So we don't need like entire thing. We just, yeah, I agree. It's more efficient. All right, moving next. Swap node in pairs. Given the linked list, swap every two adjustment node and return its head. You solve the problem without modifying the values and its node. Only values themselves must be changed. Sorry. All right, so it's simple enough. I think what we can do, we can maintain two pointers. We can, if we have a list like this, right? So 1, then 2, then 3, then 4. So swapping will be we assign previous here, or like call it left, we assign right here. So swapping process will be swapping process will be first. It's similar like reverse, but without 2 1 for 2. Okay, so in this case, let's say, so 1 become a center. Okay, so I can say that left and right going to head and head next, while right what we have to do, we have to assign We have to assign left. Next. Left next. We assigning whatever we have in right next. Right. Then right next. We assigning whatever we have left. And then we move into the 3 and 4. So I would say that right next has to be preserved. And then left equal left next. And right equal right next. Yeah. The return head. Oh, it's optional? Yeah. Yep. Yeah, something wrong. Rate equal rate next. Rate next equal L. So we assign. So we have to preserve left next, which is right. We have to preserve right next. Right next as is become next equal. Right next become left next. So in this case we have right yeah, left next become a right next. So we have 1 point into 3. Then right next is pointing to left. We have 1 pointing like this. This is still pointing to right, and this is still pointing to left. It haven't changed. So what we have to do, we have to move right, not to next, because it changed. We have to move right to pointing left next. And then, so right becomes here. Yeah, so we have to left pointing to left next. We choose here. And right pointing and right pointing to right next, which is here. And then we swap again. We have 4 and 3. Because we have left, next, okay. We have flags. So, okay, let's print right value and left. Oh, left, right, left value and right value before and after operation. I'm just curious to see what's going on. So left, next, equal. So it's 1, 2, 3, 1. Why? 1, 2, 3, 1. It should be 1, 2, 2, 3, 4, right? Not 3, 1. What? It's showing to 3, 1. Because we signed left. And then we have 3, 3, 3, 3. But why? Why? Okay, 3 before, 3 after. Is it like cycling? Oh, it's cycling on itself. Okay, so we have 1, 2, and then we assign left to point to 3, and 2 to point to 1, right? So we assign a left point to 3, and right point to 1. So also I can tell that after this head become head next, right? So we are pointing on to left pointing, left next equal right next, then right next left. So left next equal right next, and right next equal left. So we have them in this swap. Now, how we move further? We assign right to the L next. No, we have to assign left to the left next. And then we assign right to the left next. No, 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 no. So we assign left to the left next. Yeah, so we have 1, 2, 3, 4. And we swap 3, 4. And here we can tell if L next, if L. Right? Meaning that we have L Okay, so empty list if not add next, we just return add. Oh yeah. Except here. Why it's not working here? Because let me go like this, so we will break. Yeah, I can say if L, then this. If R, then this. No, I mean if L, it's still why it's not. So in the first step, right, in the first iteration, I can say if L and R, so in the first iteration we print 3, 4, then I have to trace it all the way down. So we print 3, 4, left and right on it. Then we assign L next to right next. So L next whatever has a right next, and then R next equal left. No, we must have this left and right 3/4, right? So whatever is L next assigning to right next, meaning we can I draw? Yeah. So we are assigning L to none, first operation, then right next we are assigning to 4, if L next, no. But the problem is why it's so hard to comprehend this? So we assign this to none, then we assign this to 4, right next equal L. So first we will assign L next to none, then we assign right what we have here. So first we assign what L next to right next, then we assign right next to L. Probably because we didn't fix previous. See what I mean? And this is still pointing on 3. 1 is still pointing on 3. So we're missing one operation here. As we move, we have to maintain previous end. This end, we have to maintain end of this pair. How are we gonna do it? Will be the end of this pair. It's a right pointer. before shifting. So if we save right pointer after shift, we point like this. Oh no! Total disaster. Okay. So we have left pointer here, right pointer here. First operation, what we're doing, we point this left, next is pointed to right. Then right, next is pointing to left. So we have in this position swapped left and right. Now our previous will be left, not right. And then we move L to L next, and right to LL next. And after move, we assign previous next to L. Okay, let's try. Ah, still not working. Missing 4, still missing 4. Why missing 4? Missing 1 iteration. Nope. Yeah, we need both of them to iterate. One, two, three, four. Beautiful. Why it's not working? So 2, 1, 3, but 3 connected. Why? We have 3, 4, right? We have pointing on 3, 4. So initially we have them like this, then we swapped and we have them like this. And then whatever L is pointing, whatever L is assigned, we assign prev. And then we move L to L. next, and right moved to L next again twice, and then we assign previous to L. I mean, it should be working. What is 0.213? Why 3? Okay, let's go through this again. Maybe one last time. Okay, so we have left and right here. Then we break this. We assign right next. We assign left next. What is R next? Then we assign R next. What is L? So we have R, L here, right? We swapped. It's perfect. Now we assign prev to L. Then we assign L to L next, which is here, which is 3. And we assign R to what is next, which is here. But before that, we assign prev to the L. So it's going to be here. And then we move. So we have L next. So we are going into cycle when we have 3 and 4. Right. So L next will be R next, which is now. Oh, see, pre next we assign to 3. It's correct. Pre next assigned to 3. This is why we have 3 but not 2. So we assign L next to now. Then we assign R to here. So this is still pointing here. That's the problem. It's pointing to 3 and then pointing to now. So previous, when I'm assigning previous, which is 1, which is left, should point to right after all. Previous next should be right. Is it a problem? Okay, memory. It's probably cycled somewhere. Okay, let's try again. So we have left and right pointing here. Then in this line, we point L next to here. And we break this. Then we point right next to L. Okay, so we have a like 1, 2, and then right next to L. Okay, this is this one. We assign previous to L, which is this one. Then we move in L to the L next. And then we move R to the L next here. And then we assign previous next to the R. Then we go for 3, 4 cycle. We assign L next to the R next, which is none. Then we assign R next to the L. We are not moving, we move in L to the L next, which is none. And we are not running this too, but we assign previous, which is 1, with R, which is 4. Yes. So as a result, we should have, and we start with head next, we start from 2. We have 2, 1, 4, 3. No, we still have. See, this is a problem. So previous was assigned to 2 and previous next. Okay, so previous was assigned to 1 and previous next Dira assigned to R. Okay, it should be working, but it's not. And the question why it's not working. So we have start from here, head next, 2, 1, 4, 3, none. 2, 1, 4, 3. This is what we should have. Okay, can you print this? All right, I'm gonna take a break. It's almost an hour, and yeah, we'll be see you on part 2 of the same problem. Bye.